Hello students. In previous session, we learnt about the following topics: electric energy, electric charges, and electric current. And we also defined the unit of electric current. So electric energy would be the energy harnessed from electricity. With respect to charges, we have two kinds of charges, positive and negative. When the charges flow, it constitutes electric current. And when 1 coulomb of charge flows through any cross section of a conductor for a time period of 1 second, we can define it as 1 ampere, and that would also be the SI unit of electric current. The first topic of this session is electric circuit. Now first let us try to define what is electric circuit. A closed and continuous path through which electric current flows is known as electric circuit. I repeat the definition. A closed and continuous path through which electric current flows is known as electric circuit. Now, let us consider a very simple example to understand electric circuit. In a torch, a switch provides a conducting link between a battery and a bulb. When the switch is turned on, an electric current flows through the bulb and it gives light. Such a continuous and closed path of an electric current is called an electric circuit. And when the electric circuit is broken at some place, or say if the switch is turned off, the current stops flowing in the electric circuit and the bulb does not glow. Hence, any closed and continuous path along with an electric current flowing is called electric circuit. Now, let us learn about the various components of electric circuit. These components are as follows: an electric cell or a battery, a load, say a bulb or any other appliance, a switch or a key to open or close a circuit, and sometimes we also consider a fuse. All these components are connected through wires, and these wires are generally made of copper. An electric circuit can be in two modes. One would be a closed circuit and the other is open circuit. We've already learned that a switch or a key is one of the components of electric circuit. When the key is closed, then the circuit is said to be closed circuit. This means that the current would flow through the circuit to operate the device. Whereas when the key is open, the circuit is said to be open circuit. This means that the current would not flow through the circuit. Hence, we can also define an open circuit and closed circuit as follows. An electric circuit through which no current flows is called an open circuit, and an electric circuit through which current flows continuously is called as closed circuit. Now let us revise whatever we have learned till now. Any closed and continuous path along with an electric current flow is called as electric circuit. When the key is said to be closed, then the circuit is said to be in a closed condition, that is called as closed circuit. This means the current would flow through the circuit to operate the device. Whereas when the key is open, then the circuit is said to be in open circuit condition. This means that the current would not flow through the circuit. That was all about electric circuit, open circuit and closed circuit. Now let us try to understand what does the circuit diagram mean. Circuit diagram is a schematic diagram which represents the relative positions and connections of various circuit components represented by the symbols. I repeat, circuit diagram would be a schematic diagram which would represent the relative positions and connections of various circuit components represented by their symbols. A circuit diagram of an electric circuit having cell, electric bulb, ammeter and plug key is as shown in the screen now. Now let us look at some of the commonly used electric circuit symbols in an electric circuit. In this picture, the electric circuit symbols of electric cell, electric battery, and bulb are visible. This picture contains the circuit symbols of plug key or open switch, which is in off position, plug key or close switch, which is in on position, a wire joint, and a wire crossing without joint, also sometimes called as jumper, and the symbol of a resistor. This picture contains the circuit symbol of a variable resistor or a rheostat, ammeter, and an voltmeter. And these were some of the most commonly used electric circuit symbols in a circuit diagram. Now let us learn the functions of some of the components used in an electric circuit. Let's begin with ammeter. Ammeter is a device employed in an electric circuit to measure the current flowing in the circuit. Next, voltmeter. Voltmeter is a device used in an electric circuit to measure the voltage or potential difference between 2 points. The readings we consider from an ammeter would be in terms of milliamperes, microamperes, or ampere, and the readings from voltmeter will be in terms of volt. There are two more components we have to learn about. They are one resistor and the other rheostat, or also known as a variable resistor. Now let us learn about a resistor. A resistor is a circuit component that would control the flow of current in a circuit, and we will learn that flow of electrons is what would constitute the current. When we say that the resistor is a component that controls the flow of current, this would also mean that a resistor would control the flow of electrons or the flow of charges in a given circuit. This circuit component, named as resistor, which has the property of resistance. The property of resistance would mean the opposition offered for the flow of charges in an electric circuit. This would result in controlling the value of current in a circuit. This means to say that in an electric circuit, whenever we have more resistance, we can observe less current, and whenever we have less resistance, we can observe more current. Hence, resistor is a component which has the property of resistance, that is, to oppose the charges in an electric circuit. More is the resistance, more is the opposition offered for the flow of charges, and less is the current. And if less is the resistance, less is the opposition offered for the flow of charges in a circuit, and more is the current. So resistance and current are inversely proportional. Hence, resistor can also be termed as a current limiting component in an electric circuit. That was about resistor and the property of resistance. Now let us learn about a rheostat or a variable resistor. A circuit component which provides variable resistance in an electric circuit is called a rheostat or a variable resistor. Rheostat is a variable resistor which is used to control the value of current in a circuit. They are able to vary the resistance in a circuit without interruption. This rheostat is also a special type of resistor that can manually be adjusted to manipulate or control the amount of current flowing in an electric circuit. It is modeled as shown in the diagram, and its working is as follows. When you start moving the sliding contact to the terminal B, you cut more and more resistance out of the circuit, reducing the resistive path that current needs to take. Hence, this would increase the value of current in the given circuit. Whereas, if you move the contact to the terminal A, you take more and more resistance in, and therefore this would decrease the value of current in the given circuit. The rheostat seen in the image is a slide kind of rheostat or slide type of rheostat, which is more often used for educational purposes in laboratories. Now let us recall all the four components we have studied till now: ammeter, voltmeter, resistance, and rheostat. Ammeter is the one which is used to measure value of current. Voltmeter to measure voltage or potential difference. We'll learn about potential difference in the next topic. And resistor is a device which has a property of resistance which opposes the flow of charges. Whereas rheostat is a device which is having the property of variable resistance. And by varying the value of resistance, we can also vary the value of current.